Hi, and welcome to IoT All The Things. My name is Wale Oladihin. I'm the Worldwide Technical Lead for AWS IoT, and I'm joined today by Ben Kehoe.
Hi, I'm Ben Kehoe. I'm a Cloud Robotics Research Scientist at iRobot and an AWS serverless hero.
Yeah, it's really exciting. This is our first IoT All The Things kind of Twitch session, so there's a lot we want to cover, not just in this session, but as we create more episodes on Twitch. To give you an idea of what we will cover today, we definitely want to give you an idea of what is recently launched with AWS IoT services. And then we're going to spend a bunch of time diving into security and connectivity on devices, as well as once you start getting messages from devices, what the heck do you do with them? Along this entire kind of journey, we'll be diving in with Ben so we can talk about not just robotics, but how iRobot's thinking about the cloud, enabling new products and features, and essentially building some really, really cool things on top of AWS. With that, I would actually like to dive in a little bit more, Ben, because I know that we've actually had the pleasure of working together now like 4 years.
Yeah, quite a while.
Ben was, funny enough, my first customer at AWS. And I would say you've definitely been like pushing the envelope about how you think about the cloud. So could you just talk about like what's been so exciting about your move over these last now 4 years?
Yeah, well, it's been great because we've been able to, iRobot has been traditionally a hardware maker that now makes cloud connected robots for the consumer space. And as part of that, we haven't had to go through a period of learning how to build and scale cloud infrastructure. Because with managed services on AWS, we can skip that step and focus on building value for our customers.
Nice. I know even as you started, I think the first thing you were doing is just how do you kind of enable this to begin with? But it seems like since then you've been getting into new products, but then also enabling all kinds of interactions with your robots. So can you speak about some of those kind of fun things you've done over time with the kind of broad reach you have with AWS?
Yeah, well, AWS IoT is sort of the crux of our system. It enables connectivity for our robots and for our mobile apps, and sort of is our entryway for our robots into the cloud. And behind that, we use about 30 other AWS services to deliver that sort of one application that supports our connected robots and apps. And all of our computation is based around AWS Lambda. We don't have any EC2 and no containers in production. And then, storage in DynamoDB, streams through Kinesis and SQS and SNS, and Athena for analytics, right? All of these different services that we bring together that all, don't require us to understand the running of the infrastructure underneath. They just allow us to accomplish the business goals that we have.
Yeah, I'm thinking about when we first got started, what's probably one of the funnier things is, I remember one of our first meetings, it was, we have to do everything serverless. And I was like, I just don't even know how we're going to do that. Like, this thing's new. But kind of seeing how you just like push the envelope there, especially with IoT Core being something where you don't have to manage the infrastructure, but then digging in further and saying, well, we want our business logic to run, but we don't want developers to just have the SSH in and start patching and doing updates. So it's been pretty exciting to see. So just curious, like, what are you starting to work on now? Like, what's your kind of things you're digging into next at iRobot?
Yeah, well, we've been starting to enable, digital features that are based around sort of our understanding of our customers based on the usage of our robots, right? And so this means, understanding things like, if the customer is using the robot on, at the same time every day, we can suggest, hey, do you just want to schedule the robot? Right? Part of our value proposition is, less interactions with the robot.
Yeah.
As a brand, you want engagement, but we also want the robot to give people time back in their day.
Yeah.
Right? And actually, so, as part of that, right, our new i7, right, our new fancy robot, has a base that empties the bin when it goes back on, right? Which means that you don't even have to empty the bin every time it gets full, right? So you can go longer without the robot requiring you to interact with it.
Yeah.
I'm
about to say, like in our house, we run the room, and my wife is like, before I go to class, she hits the robot button, basically the same time every single day, and then even on top of that, she hits the button, I come home and I clean the bin. So.
Yeah.
You
Right.
can solve both of our challenges
Well,
at the same time.
and that notion of being able to reach out to customers and say, hey, there's this feature that you haven't considered scheduling. Maybe you didn't know about scheduling, or those kind of things. But it took me a couple of years of working in both serverless and on Roomba to realize that the value proposition is the same.
Mm-hmm.
It's giving you time back in your day to focus on what matters to you, right?
Great.
And for iRobot, that's building value for our customers. And for our customers, it's not having to vacuum. Right?
Yeah. That's so cool. And so I know, like, we started diving into your use case a fair amount, but for everyone that's on the Twitch channel right now, it's something where people try to figure out, okay, great, like, I understand I can do all these business objectives, but I don't know that much about some of the main AWS IoT services. So what I want to do is, I'm just going to quickly kind of do a level set on what's available with AWS IoT in terms of the ecosystem of services. And then over the next part, we're diving a little bit further with Ben, especially around the security and then like the really fun stuff around robotics and the rules engine. So if you're seeing my screen, hopefully it's up on Twitch, but there's tons of services in the AWS IoT ecosystem. So if we kind of start at the bottom, those are all our device services. So that's like, how do you get something connected? Like, how does a robot actually talk to the cloud? So you can use our SDKs, you can use Amazon FreeRTOS or IoT Greengrass to run things at the edge, and of course enable connectivity to the cloud. Then we have all our control services, and those are things like device management, device defender, IoT Core, and things graph. Essentially, once you have this connectivity, how can you start interacting with your devices, building new products on top of it, and then making solutions around what your device behavior actually looks like? And of course, what everyone wants to get to is that kind of panacea where you're like, I have all this data, and because I'm doing data, I'm doing ML and I'm doing analytics. And so we said, let's build some more services here as well. So with IoT analytics, Sitewise, and IoT events, you can do things like machine learning, predictive maintenance, classifications. You can even do your own kind of state machine logic inside of the cloud.
None of which, in IoT analytics and IoT events, I like to point out that they are not specific to IoT, right? That they're built as part of the IoT suite, but if you have sort of time series data that you want to run queries on, or you have little state machines that are event driven that you want to track, those are applications that lots of people have outside of IoT and should not shy away from using these services just because of the label.
Yeah, it's funny. I get the opportunity to meet with customers and have a lot of non-IoT use cases looking to use IoT. Like, oh, well, you know what, we're doing chat applications, or, we want to do ingestion, but there are a bunch of just like computers that people will like open up, and then we're taking like information off the computer itself. It's not a thing, it's not a button, but it is something with compute. So it is funny as you're bringing it up that we're seeing customers kind of look at all of these services and say, well, this one makes sense for me. So that's like really nice and flexible within the platform. So I mentioned there's kind of two services we do the most diving into. One is AWS IoT Core. So as Ben and I were chatting, this is actually where they started their journey with IoT Core, which is really the service that manages the connectivity. That's what the device gateway and the broker does. Like, how do you send messages? Like, how do I know that I need to have this Roomba start cleaning? So being able to associate the connection with the actual thing. And then kind of further to the right, you'll see things like the Rules Engine, Device Shadow, and Registry. The Rules Engine is where you route your messages. So we'll dive into some best practices around the Rules Engine, but think about when a message comes in, that message is destined for Alexa. So if I want to control my Roomba through Alexa, it's got to be able to say, well, do I route this to Alexa, and where does that go? Similarly, if you want to do your analytics internally, you can say, I want to route this to Kinesis Firehose. So the Rules Engine does that routing for you. And then Device Shadow and Registry do all of the kind of desired and reported state. Like, what is the current state of my Roomba? Is it on or off? And then the Registry is just static information. Things like the serial number associated to a device. Things that you want to register once. Think about that as well, Ben. I know we had a bunch of back and forth. We were trying to figure out where the heck to put all this stuff. So it was like, it's got to all live in the Rules Engine. And they're like, no, that's not right. Like, instead of the Rules Engine, we're going to put it in the Shadow, and then not the Shadow, not the Registry. And you kind of over time started to figure out what makes the most sense, and any kind of thoughts there for people who are reviewing now.
Yeah, I think a good example of what we keep in the shadow is the robot schedule. So the schedule lives on the robot because if your internet is out, if it can't talk to the cloud, it should still be cleaning on its schedule, right? And so it reports its schedule up. And then if the app wants to set the schedule while the robot is offline, it should still be able to do that.
Mm-hmm.
And so it sets it in the desired section of the shadow. Then when the robot is online, it can see that it's got a requested change to its schedule, set its schedule internally, and then report that back to the cloud in the reported section, right?
Got it.
And then those changes then flow out through the rules engine, right? We listen to all the shadow changes, and that's how we can trigger, certain events that happen when certain changes happen in the robot, or just for analytics to say, here's all the counters of number of missions that it's gone on, right? And we can see how it's done that, report back, when a filter needs replacement,
mm-hmm.
right? Those kind of things we can tell users about.
Nice. And then even to the left of it, when we start getting into the identity, this is also really interesting because with IoT, it's almost always about identity and security. So we're spending a lot of times with customers basically saying, okay, how do you secure your devices? How do you secure the information that's on the device? And how do you make sure you can send that information securely to the cloud? And AWS IoT kind of has a ground floor for that, just out of the box, where we use X509 certificates, mutual TLS 1.2. And so we kind of set this high bar with security. But it would be interesting to know too, Ben, I remember we were chatting about how we do things like uploading stuff to the, things that aren't telemetry, but maybe, larger payloads up into the cloud. And it would be great to just dive into when you start thinking about security, not just the device security, but then how do you use that like certificate, that identity to start talking to other services? Yeah,
and it's great, the certificate-based authentication is great for devices because you can install AWS IoT Core has bring your own root certificate authority. And so you can have one signing cert for your company or a set of signing certs for your company that you install once in AWS IoT. And then any device that's connecting that has a certificate that's signed by that root CA can then be allowed to connect. And that means that in the factory then, instead of creating identities that you then have to individually transport to AWS before the customer tries to register the robot, those processes are decoupled. Mm-hmm. All you need is that you can sign those robots in the factory and you've installed the root CA on AWS IoT. And so that's logistically for manufacturing and IoT, that's
much easier.
Fantastic.
It's amazing when we'll meet with customers and it's like, okay, I'm doing my manufacturing. It's overseas in China and there's no outbound internet. I'm like, you know what? As long as you have an HSM there and you're burning certificates, whenever those devices come up and they connect, we can do it at that point in time. And that kind of, as you mentioned, decoupling, the fact you don't have to go, okay, once an hour at the end of the day, someone's gonna have to take this box, put the LAN in and sync a bunch of certs, just makes life so much easier. And if you're starting from scratch, right, AWS has partnered with a chip maker to make microchip, Atmel chips. That so you can buy just identities as chips that you put on your PCB and be done with it, right? So you don't even need to go the route of setting up your own identities, right? If you're starting from scratch, you can bring that in a very simple way. Mm-hmm. The other piece then is that the certificates are great, but they only allow you to connect to AWS IoT Core. And so at that point, the robot, the rest of the power of AWS is only available to it through AWS IoT Core. And so, used to be that if you wanted to have a robot invoke a Lambda to find some information out, you have to send a message to IoT Core. There would have to be a rule on that topic that listened to it, invoke the Lambda, and the Lambda had to publish back into IoT Core. Yeah. It's now possible to get AWS credentials, SIG-v4 credentials, from AWS IoT using the certificate-based authentication. Yeah. Right? Yeah. And so... Oh, go ahead. Yeah. And so now, right, once the robot has those SIG-v4 credentials, if it understands them, then it could invoke that Lambda directly. If those credentials were given that permission, et cetera. For us, we wanted to avoid having, that system didn't exist when we were beginning to build these things, but also having that SIG-v4 signing on the robot was more than
more complexity than we wanted to deal with. And so luckily for things like file upload, S3 has pre-signed URLs, right? So the robot can request, I have a file to upload, and that goes out to through IoT Core, through PubSub to a Lambda, generates a pre-signed URL, and returns that, and then the robot is just making a plain HTTPS put to do the upload.
I see. So I know when we talked before, it's also just in terms of like Wi-Fi connectivity, you just don't have room to essentially store all of these like short-term credentials.
Yeah.
So, if you're dealing with really constrained devices, you can't have, multiple certificates because it's the private key, the cert, the root CA, and it's like, every so often we're going to send you, 2 more temporary keys. And so now you need to store 5 of them. So I remember we talked about that. It was just like, that's just never going to work on your robots.
Luckily, the new ones are getting a lot smarter. There's a lot more capability for those kind of things, but we still have the constraints on a lot of our robots.
Yeah. And so if we actually flip back to the presentation, like kind of if I illustrate what you're doing is you're kind of doing that authorization over MQTT. So, in your case, you're using the shadow, but you have some kind of MQTT message that goes up. It triggers a Lambda or triggers something in your backend to say, I need credentials. And as you know, there's a couple ways to do this without doing just a pre-signed URL. You can go the pre-signed URL route. So in your Lambda, you can just say, here's a URL, let me put it on the shadow so you can go get it, 15 minutes later if you need to. You can also do that same exchange using something like a Cognito or IAM STS, which are actually maybe dive into the console and show. But in the end result is that you're now able to take your devices and not just use that one identity for AWS IoT Core. You can start enabling it to talk to several different services. It might be S3 today. It might be a custom API gateway endpoint that you need to go post some information to later. Just gives you a little bit of ways of trusting that identity that you have and essentially allowing it to federate to other things. Cool. Maybe what I'll do is I'll actually just hop into the console and we can kind of talk through how these might actually work. So. But I have so many screens on, it's a battle to find the right one. Yeah. So, you kind of have 2 options in AWS IoT. I'll make this a little bit bigger. It's a little bit better. As Ben mentioned, you can do like the pre-signed URLs. So you can basically say, I'm just going to take a URL from a service, pre-sign it, and then it's like push it directly down to the device, which I think is like super flexible and awesome, like no keys you have to deal with at all. You can also do something where in your Lambda function, you can essentially say, when I get a request for a set of certificates, really session tokens I need to generate, I'll find a role that device is going to assume. I'm going to then figure out where it needs a response back, so which topic to send it to. And I can call a number of APIs. So in this example, I'm going to use assume role, but I can do something like get session token or assume role with web identity. Essentially, I can call any of these kind of commands. So my get session token command or my assume role with web identity. And a nice thing with each one of these different STS calls, it just kind of depends on how long you need that permission to live. So let's say you've got to do an API call for the next 12 hours, or you need it for an hour time period. You might pick one call over another. Or in a case of assume role with web identity, you can actually pass a policy in on the fly. So let's say I need to troubleshoot this beta robot, but it's to a beta endpoint and I need just this device to get this information. You can essentially generate a new policy and say, okay, beta robot, you can only use this for the next hour. But by hooking up this Lambda function, I'll obscure some things here, but I can essentially publish on the topic, get this information out, get us sent temporary credentials, and actually publish out onto a completely different topic. And then that would be the device we listen to. If you actually want to see this code, I can post this to the Twitch room so you can actually see the gist for this, for what's happening. But actually show that this code will work. I'll open up IoT Core. I think one of the fun things with the IoT Core that I use probably more than I should is actually the test MQTT client functionality, because sometimes you're like, I have no idea what's going on and I'm just going to go listen. So now that I have this information.
I mean, that's a great strategy in life. I don't know what's going on. I'm just going to listen.
I'm just going to go listen. Yeah, that's probably, it's like, I'm going to tell it to my wife. Like, I'm going to come home and be like, I don't know what's going on, but I'm just going to listen to you. So cool. So to give an idea what my test function will look like is, again, I'm passing in a payload. This just to make it a little bit easier for myself, but I'm going to pass in a role to assume. So again, if I'm using something like web identities, I don't really need this information. I just need to know who's the thing asking for it. But just for test purposes, I'm going to assume this role, take the role arm, and then publish on this like return topic. And so I can actually listen that this works. Most of the time it works. I'm going to subscribe to the same response topic. So when I hit kind of test my Lambda function, assume that test is coming from a device, but I'm just triggering in a console. It'll pull information, send it down to the device. And in this case, this device is allowed to go and upload to a service like S3. So in the cases where your device is a little bit more powerful and you're like, I want to give you temporary credentials so you go sig before sign and make a bunch of other calls. Once I hit the test, what I'll see on the other end of that test is I'll basically get the credential information. And I could downscope this a little bit because the device probably doesn't want all the stuff like the response metadata. But I can give it the secret access key, the token expiry, and access key ID. And then it can go off and just run with it. And this allows me to do all of it over MQTT. So I haven't actually made any changes in terms of where the device gets its information from. It still happens over MQTT. The other kind of use case you can do this for is, let's say you actually have a device that can go over HTTP. You might want to instead use some of the interactions that Ben mentioned, which is we released a completely different way of getting credentials where you actually post to HTTP endpoint. So there's a lot of moving things here on this slide, but the main takeaway is that instead of going over MQTT, what you do instead is you make an HTTP call to us. And behind the scenes, instead of running that Lambda function that I basically wrote and ran, AWS actually goes and assumes a role for you and then returns credentials over HTTP. So we're trying to reduce the number of Lambda function calls you have to run, and then just kind of manage it for you. And the same thing you can do with IoT and AWS in terms of like going to go talk to another service, you can just do directly. So just kind of interesting, Ben, as well. I know it's something where you kind of, as things move really, really quickly, you're like, oh yeah, there's tons of services. I love to kind of get your thoughts as you start looking at things and go live. What's your decision of whether you pull them in, like whether you decide to use them, what ends up being a good fit for you? Because if there's anyone that's on top of new releases, I feel like it's you.
I try to be. At the very least, to evaluate what they're named.
That's true.
So I think
you me on a name.
Yeah, and I think just to finish up, I think that ladder method that you mentioned, right, is in general, once you get those SIG-V4 creds back, you're going to be making an HTTP call anyway. You should use the thing with fewer moving pieces, right? Mm-hmm. It's a way of using essentially reducing that pain point of having to wait for an asynchronous response through MQTT. Right? It's all there in a synchronous call that you get. So we think about using new services. I mean, there's always a few things that we evaluate. One of the big ones is does it have CloudFormation support? Doesn't have CloudFormation support. How hard would it be for me to build a custom resource to do it in? Because knowing how to make CloudFormation custom resources is a force multiplier. Like it's an extremely valuable skill.
It is an art in a sense.
Well, we tried to make it very easy, right? We have on GitHub, we have a custom resource library that tries to make all of that as simple as possible. Because we found that just being able to set up those custom resources to control, whether it's an AWS service that doesn't have CloudFormation support yet, or a third-party service that you want to control, or I once said that you could control anything with CloudFormation custom resources, and a friend of mine challenged me to control smart home light bulbs. And it took me about half an hour, and most of that was wrangling the
Weather
API. Yeah.
You're like, where in the docs is that?
Yeah.
You're like opening things up. Yeah.
So CloudFormation is important. How well it supports sort of evolving deployments, right? When you have to change something about it, is that going to be hard to do when it's live in production, or is that going to be easier? So those are things that we look at. But in general, we're not afraid to say, yeah, that accomplishes something that we're trying to accomplish. Let's go with it.
Yeah.
Because we know we can rely on it to scale to the levels we need. We know that it's only going to get better over time, right? Usually when services launch, the number of CloudWatch metrics that they expose is not enough for you to see everything that you need to see. And so like when we launched with AWS IoT, it had a handful of metrics.
Yeah.
I'd say it was like 7.
Yeah, it was under 10. I remember.
And there were plenty of ways that we could use the service that would cause it to, perform badly for us, right? That we would be using it in a way that was not optimal for us, that we couldn't see that we were using it badly. And now it has like 60, like
it does.
Enormous number of metrics, and we can see.
I'm sure
all the
many
ways.
of them were requested by you and I. Remember, like, wait a minute, like we need these metrics,
and now that's great, right?
Yeah.
And that knowing that it's going to get better over time, and that the things that are hard today are going to be easy later. Makes it, when you look at the value that a given service is going to provide, you consider sort of that long-term value and say, well, if I have to build this myself today, I'm going to have to own that forever. And that's only going to get harder as it gets older. Whereas an AWS service that I select is going to get easier over time.
Yeah.
Right?
No, that's really interesting. And I think there's like that balance too, because you can start with core, and then, I showed that slide with all the features like the shadow and the registry and, identity. If you connect to us, you have to use the identity service. But like all of the kind of intricacies, once you're in the cloud, you can kind of pick and choose at the right time when to use it. So like that kind of Lambda hook to go get credentials, again, could easily be replaced with, okay, we start with pre-signed URLs. We don't want to push credentials down. We don't want to manage them. So, just go upload to this. And then over time, you're like, you know what? Like, we want to change that to a Lambda function. We want to get STS credentials back. And then you're like, okay, maybe even more so, we want to make an HTTP call. And then that one gives a different set of credentials back. But you have that flexibility where even across one deployment, you probably have robots that are doing, on different versions doing slightly different things. And you have to be able to support that like life cycle of when devices actually pick up their updates and have that functionality.
I try and explain IoT to people who develop like web apps. IoT is like if some of your users had browsers that just would never refresh, right? And so content you served
Is that IE6?
2 years ago, content you served 2 years ago is still hitting your APIs, right? And so it's definitely something where even when you evolve. What the cloud is doing, the robots may be doing things that you thought were a good idea a while ago and may have changed your mind since then, but
that is awesome.
Yeah.
So I mean, we showed that kind of first way of doing it. So like I'll bring that back up on my screen just so people have an idea. We have our Lambda function. That Lambda function makes that STS call. Once it gets that information, it just publishes it back on the response topic. So like that's something that you can do if you're just using IoT Core. If you wanted to follow that, just again, I'll post it on the link, but I'll leave this up just for a little bit. If you find me on GitHub, you'll be able to kind of get back to this code snippet just so you can run it yourself. But just deploy it on Lambda, and Lambda takes care of actually running the compute for you. So it's pretty straightforward. But then, as Ben mentioned, we started releasing other services, and one of those is, if you can support HTTP. So we'll see this in cases where customers are, they have a bit more compute. Maybe they're doing things like they're streaming video streams up a period of time. This is actually using Kinesis Video Stream as an example. What they want to do instead is, they're already using like HTTP to do their streaming. And they're like, well, we don't want to open up another MQTT connection because like we may not have metadata to send, but we do need credentials. So what you're able to do is you basically get a secondary endpoint in AWS IoT, which is basically like your credential endpoint. So through that credential endpoint, you can actually pass in header information, like, which device is this, and like, should I trust this device? What is it trying to authorize itself as? And then similarly to that Lambda function, you can basically get a set of credentials back. You can basically say, I want, on Kinesis video auth thing, and I want to get information about me so I can publish to my Kinesis video stream. And so like if I go in and actually run this example, what's going to happen? I can run in the right place.
And the reason I want to do this is because it lets me get rid of a Lambda and a rule.
Exactly.
Which is less stuff for me to maintain.
Exactly.
Lets me do other things instead.
So I'm an old man, I do everything in Java, but what you'll see is that it basically like stands up and says, okay, I've got a stream. The stream is the same thing as my device. So I'm making this mirroring between the Kinesis video stream and actually the device endpoint. And IoT can say, well, we know you're this device, and so we'll give you temporary credentials for your credential endpoint. So like, this is the endpoint that I'm actually calling, and then this is the credentials that actually gets returned from it. And what's happening now is I'm just using that to go stream to Kinesis video. So if I end up going into the console, and if I can actually find the right Kinesis video stream, one of these will be right. It should be this one. So the stream matches the thing name. So again, taking that same identity in IoT and basically saying, I know that this thing I trust, this thing has a certificate, and this thing also has something in another service. It's got its own path in S3. It has its own Kinesis video stream. I want to allow you to go talk to it directly. And then this is just our sample application, but it's basically just streaming in a loop. So it's like streaming this over and over again in front of the device. And now my example camera, I don't have to go hard code AWS credentials. I don't have to potentially have that MQTT connection. I'm using a completely different service in AWS IoT just to get information that I know about the device, and then go and say, go talk to that other service directly.
And this is like what you're enabled to do with Cognito and mobile users, right?
Yeah.
Cognito allows you to have a role associated with a user pool that lets the Cognito users go and invoke other services directly rather than going through, API gateway or something to accomplish those.
And I always give the analogy, it's like the difference with devices is they don't have Facebook accounts. So it's like, Cognito, it's like, okay,
yeah,
that is true. That's how you get the next bump of users on Facebook. Like, let's connect all the things and have them post to social media. But yeah, it's like that same kind of challenge. You're like, mobile phone, gotta go talk to this stuff. And like, thing, I trust you, but you gotta go talk to this other stuff. And then like, the ability to do that really seamlessly. So like, even in that example, if I like go back into the screen again, if you wanted to run this today, so you saw my Java code running and it's basically just uploading a bunch of streams of video. The same thing with that kind of how do you make it easier, whether it's CloudFormation or starter scripts. If you want to use Amazon Kinesis Streams, we actually built this into the base library. So if you go and search in GitHub for Amazon Kinesis Stream Producer, there's an entire IoT cert credential provider that actually uses AWS IoT credentials. So let's say you're already doing smart cameras or security systems, you can go in and just roll this yourself without having to go and like dig around and figure out, okay, Wally made an HTTP call, but I don't know how it works for Kinesis. If you download it, you do a couple builds, say, here's where I need to go create a certificate, and like, voila, it's there. And then a nice thing, as you mentioned, is that because they don't have Facebook accounts, you can still pin devices to the right stuff. Again, so you don't do anything super nefarious. Cool. So I know we've kind of dove into security angle like a fair amount. I would love to like switch gears a little bit and kind of dive into robotics, because we definitely have a robot here. So I would definitely love to hear, you kind of talked about kind of uploading and kind of the tough parts of robotics, like the constrained nature of devices. It'd be great to talk more about like other things you do on a device, maybe just even particularly what's tough, like what are the things you're struggling with, especially when you only have so much space.
Yeah, well, I think there are a lot of hard problems in robotics. right, path planning navigation, right, is one of our differentiators, that our robots smartly navigate homes, build a map and understanding of your space to allow them to clean more effectively, to allow you to say, I want you to go clean my kitchen, right? You can ask Alexa to tell the robot to go clean, right? Or to give the cat a ride. That's a fun one.
Is that a real skill?
Yeah.
That's awesome. Does it just like, does it find the cat, or no, the cat's gotta...
It just starts a cleaning mission.
Okay.
But there are a number of aliases for starting a cleaning job that are in the Alexa skill. And so, right, understanding, how the space is laid out and how it changes over time is important to us. And then, of course, the cloud connection enables us to understand better how our users are using the product, so that we can make it better for them.
I see.
Right, so that we can turn that around to give those, schedule recommendations, suggestions of features that they might not be using because they don't know about. Right, all of those things is what IoT allows you to experiment with.
Yeah.
Now, for me, I'm a cloud roboticist. I'm a roboticist that uses the internet to enable robots to do more and better things.
Mm-hmm.
And so, what I care about in robotics is how does a cloud connection enable new things on the robot? And for me, I think the future is the cloud may be running computation for the robot, which there's a balance there. You might be able to take cost out of the robot to make the robot simpler, to enable less complicated, lower cost device to accomplish more and better things.
Mm-hmm.
But on the other hand, what if it loses Wi-Fi?
Yeah.
Right?
You turn the corner in your living room and it's just like the router's like no longer visible.
And so you end up getting into robotics questions about, okay, well, what can the device be doing on its own while it's asking the cloud for a better answer?
Mm-hmm.
Right, and these are the sorts of questions you pull in. Now, sometimes if you're an industrial IoT and you can saturate the factory with Wi-Fi and you're always going to be good, you can answer those questions a lot more easily. When you have to go under, a metal bed spring that acts like a Faraday cage and you're never going to have Wi-Fi under it, you get into trickier spots.
Yeah. So I'm also curious too, because I know as you kind of talk about like that balance between blending what you run, on the device itself versus what you run in the cloud, you probably do a fair amount of just like, how do you simulate this behavior? How do you like test this out in the field? How are you thinking about even just, I need to figure out what I need to figure out before I actually go and build it. So like, what are you kind of doing in that space, or services you might be using and tinkering with? So.
Yeah. So, I mean, one of the nice things about the older Roombas is that they don't care where the ceiling is. And you can, so if they can run in a room that's this tall just fine, and you can build racks of rooms that are each this tall and run a bunch of Roombas at the same time. That's great. Now that they do visual navigation, they need to understand their environment better. That doesn't work anymore. So the problem then is you can't have 100 houses built for you to test robots in, just because you want a lot of different environments. The simulation becomes much more important.
I see.
Right?
Or you can just start building houses that are all
That's true. Well, then we can get miniature Roombas.
Just this tall.
And so I think, services, and that's going to be true for everybody, right?
Mm-hmm.
Just the fact of being able to parallelize simulation so that you can test many more different situations than you can when you have physical hardware.
Yeah.
Right? When you have a physical space that you can test in, the fidelity is going to be better because it's real physics as opposed to simulated physics. And so there's a trade-off there, but the power of testing out things in simulation first is huge. And I think that's one of the real benefits that AWS RoboMaker is going to provide to a lot of robotics companies, is the ability to say, all right, I know I want to do a lot of simulation. How can I spin up 100 simulation jobs without having to run any servers, without having to manage the infrastructure, only being charged for what I use?
Yeah. And then it does allow you to find that like sweet spot as well. As you said, like some things you're not going to know until you actually deploy them. You don't have every single model router, you don't know how all of their stacks work. So sometimes you're going to be like, well, I want to simulate decent connectivity on a bumpy surface. And it's like, well, bumpy is still kind of relative to what you can imagine, but someone's house might literally have pebbles everywhere. I don't know, something like that. You just can't actually replicate. But it gives you enough to say, we probably boiled the ocean to enough data points that we can start making some decisions about what it actually means in the physical world.
Yeah, it's about, reducing risk, right? And RoboMaker doesn't currently let you sort of simulate the cloud side of a robotics application, or especially the connectivity that might be present in one of those. But I think that's, an exciting direction.
Yeah.
Would be something that would be really nifty. And on the topic of sort of the credentials, how you access services, RoboMaker also has facilities for if you're running a ROS-based robot. RoboMaker provides tools that make it easier to access those services, kinesis video, recognition, and a couple other ones that in the same way, now you're skipping, not only do I have to not care about exactly how I get the credentials, but now my interface to it is just essentially like to the service itself.
Yeah.
And everything under that is handled for me.
Yeah.
So that's also a really useful part of RoboMaker.
Nice. And so again, like even to that IoT part, you're able to use one service to just like kind of touch the rest of the ecosystem. It's interesting too, that kind of blend with the robotics, what you do on the firmware side with what you start to get into on the cloud side. Even thinking about the cloud side, I know we kind of touched on things like the rules engine, but I know for you, it's also just figuring out how do you start routing this internally and just like sending data to the right place. So the rules engine for IoT ends up being a key part of that. I don't know if you want to comment on just how you think about, cleaning missions versus notifications versus just, the ML and big data that everyone wants to gain access to and how you tie those to your services.
Yeah, I think we use a lot of kinesis. That our rules engine, our rules tend to be not very selective. So we have sort of single purpose topics that the rules listen to them, and they maybe enrich with a little bit of context, but aren't they don't have hefty where clauses that are down selecting.
I see.
Basically, we sort of do that robot side to figure out what's important to send, and then if it's being sent, we'll pick it up and do something with it.
It's like that balance you mentioned of you have to have some logic on a robot and some logic in the cloud, and like the rules engine being is a broker in between. Yeah.
And so like at the end of a cleaning mission, it creates a little report of how many square feet, how long did it take, how many dirt detect events did it have, right? Those kind of things. Packages that up, sends it to the cloud. And that triggers a flow where that gets stored so that later you can go into the app and say, show me my history of cleaning missions, and it will pop it up there, right? That also triggers credentials delivery so that the robot can deliver the map that's created so that you can see the pattern of cleaning.
That makes sense.
And so once the robot receives those credentials, then it's able to then upload that. And then in both those cases, right, those can trigger push notifications. The user has enabled that to say, hey, your cleaning mission's done, or hey, your map is ready, right? And depending on, and there's logic that interplays there. Some of those, we're not using it for this today because this is all built before it's available, but step functions is one of those services.
Yeah.
When you look at this and you're like, oh yeah, I've got like a bunch of different little tasks to do, and there's a little flow and there's some choices that I have to make. Step functions is a really great option for that.
Yeah. That's actually really interesting. And for those that aren't as familiar with how like the rules engine kind of works, or the thinking of the rules engine, I'll like hop into my screen again just so you can see the functionality, or just get an idea of like what the service is meant to do, and then I'll hop into the console. But with the rules engine, what you're able to do is that as messages come in, as Ben mentioned, you just kind of listen on a set of topics. Like, I care about these MQTT topics related to the shadow, or a telemetry topic, or a command topic, whatever kind of really fits your use case. And then from there, you can start filtering down on those topics. So Ben kind of mentioned, you can either be like doing a lot of where clauses and filtering inside of your topics, or you might just say the topic is a filter. If a message comes on this topic, MQTT topic, just send it along. And then in the rules engine, there are several functions. I want to say it's about 30 functions you can call within the rules engine. So everything from, I need a client ID of the device, what time is it, I need to parse something out of the device. This allows you to like pull metadata out. And to kind of show how these could create some really cool examples, I'll switch back to the console and show some rules in the rules engine. So some interesting things that come up with me when I have customer conversations is, we'll kind of take that Alexa use case. You have a message come up over the shadow, that kind of temporary state to say, please turn on, please start my cleaning mission for a Roomba. So start cleaning, or take the cat for a ride. Customers would then want to say, I actually want to know, did that request come from Alexa? So did Alexa actually invoke that request? And so what you can do is, in the case of things like the shadow, you can pass some information, like let's say the client ID. So like in the client ID, you can say, if it starts with Alexa, in my own code, I triggered it from Alexa. So your Lambda function wakes up, says, pushes command down, and then the client ID, it sets it to Alexa, and then expects someone, the thing, to pick it up. But on the cloud side, you might say, well, how do I track that information? I want to know the number of third-party invocations, whether it's Alexa or a different voice service, or like an integration like IFT. I want to know when that's actually happened. So you can create some interesting things in the rules engine where you can say, I want to select everything. I also want to get essentially the name of the device itself, and I want that to be my payload. And I'm going to listen to all of the kind of incoming requests for the documents topic, which basically gives you like the previous and then current state of your shadow. But then you can kind of have this complexity in the rules engine where you say, well, I know if a request token starts with Alexa, it's an Alexa event. So what I'm going to do is I'm going to say, if my client token actually exists, so if I don't set it, like, just continue onwards, it's not an important request. If it does exist, then see if it starts with the client ID Alexa. And if that actually does start with client ID Alexa, then the where part is completely true. So like restating this in a different way, when a request comes in, you can say on the fly, is this a request that I actually care about? And I can use something like starts with this value, like Alexa. I can use things like if it's in a given range. And then based off of that, I can actually route it to another service. And in this case, I make a ton of use of republishing to see where things are. But I could republish this. I could put it into a different analytics workflow to say who's our most popular third-party applications and essentially rank them. And this gives me a ton of flexibility that's kind of driven in the rules engine. And I think the nice thing is, you pointed out, Ben, you can kind of figure out where you want this logic to live. Like if your device has logic that wants to run locally, you can do all of that functionality locally. If you want to have something where the device might send you a little bit more metadata, then the rules engine kind of dictate what happens next. You can put it in the rules engine, or vice versa, as you mentioned, you might say, I'm going to forward this all off to another service like Kinesis Streams and have it do the processing even further up in the cloud. So you kind of get that kind of, choose your own adventure novel book to read. So that's like super cool. To extend on this example further, if you're using the rules engine, if I bring up the presentation again, what you're also able to do is extend that same kind of logic, not just in the select statement, but also in the actual downstream service that you trigger. So having this as an example, let's say mission comes in, so a mission complete, or more importantly, let's say you have your mobile phone and you want to get a status that your flight's delayed. And that mobile phone is attached to a specific SNS topic or SQS topic, so it's pulling from somewhere. On the fly, what you can do in the actual where do I route this to, you can apply that same rules engine logic. You can say, well, if I know the first part of that topic is the queue itself, or the name of the queue, or the name of the ARN, I want you to go to ARN, let's say request SQS. So anytime someone requests where their flight is, they'll have request as the first part of the topic, and we'll send it to request SQS. And then vice versa, let's say it's just generic telemetry, like, yeah, I arrived at my airport. You don't have to create a whole nother rule. You can, again, kind of do it from the rules engine. So it's one of these like balancing acts.
Yeah, which saves you money.
Yeah.
Right? When you look at this and you're like, that looks really complicated. Why wouldn't I just have a request SQS rule and a telemetry SQS rule?
Because they're both
or
trigger.
command and data rule. Yeah. Whenever a rule is evaluated, you pay a fixed amount, and then if an action is taken,
It's different.
I think the first one is free. It's defined in a weird way, and I can't remember exactly how it works. But the point is, the fewer rules that you have to evaluate on a given message, the less you're going to pay.
Yeah.
Right.
Yeah.
And we push that even further upstream to say, try not to send anything that you're going to drop.
Mm-hmm.
Right. So that every time a message hits a rule, let's try and make sure that rule evaluates
It's
security.
actionable. Yeah.
Which for IoT, depending on your cost model, can be very important, right?
Mm-hmm.
Whereas if there are a lot of, especially industrial IoT cases, where streaming a lot of the data and deciding later what you're going to make use of and what you're not is completely feasible, right? And then it's a little easier to put it in the cloud further in, where it's easier to tweak and change later. And so you have this suite of options from device all the way deep into the cloud to decide where you're going to start filtering messages.
Yeah, and I think that nice balance, especially like in that rules engine example, as you mentioned, is just like, if you have really simple logic, like again, your device just kind of tells you, I'm doing this or that. Or, I'm doing 2 or 3 different things, and they always go over the same topic. You can then like choose the right upstream service essentially on the fly. So like the same thing I did with SQS or SNS, you can do with Kinesis. You can say, this is telemetry, it goes on the telemetry Kinesis stream because that gets processed, once every second, and we don't need that information. But if the same thing comes in and it's an alert because, a device is stuck, that can say, okay, well, that goes to a completely different path. Let's go to a stream that maybe has the WebSocket connection open on the other side. You're pulling it much quicker. Yeah. So you can kind of then say, I've got these 3 similar services. They're all Kinesis, they're all SQS or SNS. And I just got one rule to rule them all. So, cool. So, we dove into a little bit on the security side and the rules engine side. I'd love to just kind of maybe step back as well as we kind of get towards the top of the hour and just maybe kind of, if you're thinking about, you've been on this path for a long time, like you've had a ton of experience just like iterating in the cloud. If you could leave like the Twitch viewers with just some snippets to think about, like some recommendation as they start their IoT journey, what would you say to them?
Always remember that technology is not the point, right? That the purpose of any technology that you're using is to deliver value to your users. And so I always ask, for any technology that you have, is there any part of it that is not fundamentally building value, like is not providing business value? And if so, can you find a different way to do it, right? And so this is where we look for managed services wherever possible. Right? And when we look at managed services, choosing them by what's the one that's going to take the least time out of the least resources from us, so we can apply those resources towards actually building features. Yeah. Right? So that we can stay focused on creating value for our customers rather than maintaining cloud infrastructure.
Yeah, you were like, I want to do the least amount of undifferentiated heavy lifting I can do, because someone else is doing a better job of that or another job of that for me. So
and if we were running, we got to choose this sort of greenfield, so we were able to build all this up. And if you have existing legacy applications, there's definitely valid reasons to be choosing technology given the constraints and the realities that you're living in.
Yeah.
But if you're greenfield and you're looking at, I want to build an IoT broker that runs on Kubernetes, right? How does that make you a better IoT company, right, than using something like AWS IoT?
Yeah.
And the answer is almost always it doesn't, right? That when you can take something that's fully managed and you don't have to worry about scaling, right? When we have, when we sell very well on Prime Day, right? We don't have to worry about the influx of robots 2 days later when those robots arrive and everybody unboxes them, right? That's all handled for us. And it means that instead of having cloud developers and cloud operations focused on how do we get all those robots registered and make sure everything's working well, they're going about their normal business. And that's really powerful for us.
Awesome. So, we've touched on a lot of this kind of like, kickoff series for IoT All The Things. So just to recap, we dove into kind of iRobot's use case and really journey to the cloud. Of course, picking Ben's brain was always fun to do, especially not at reInvent when we're kind of running from place to place and talking over a coffee. Then we kind of dove into the security parts of AWS IoT. So hopefully you can take away from there, like not just you get an identity with AWS IoT, but start thinking about ways of taking that identity to go talk to your other services, right? Like you don't have to do everything over MQTT. You can say, I want to take some credentials and I want to post it to S3, or I want to stream a video for Kinesis video directly to Kinesis. We want you to use this as the anchor, but then like try to take advantage of the other services, right? Remove the undifferentiated lifting that you don't have to do. And then we kind of dove into the rules engine, which is really interesting with robotics, where you're trying to figure out where does it make the most sense to do, and then running simulations about that. How can you simulate what we think makes the most sense to do, and then decide where to put that, whether that's on the edge, on a device, in the rules engine, so using things like the case and where and prefixing, or even further up in the AWS cloud. So it was super exciting, Ben. We were told we have to do this again. We'll take a look at the Twitch comments to see if there's some general questions, but thanks everyone for your time today.
Yeah, and you can find me on Twitter and ask me further questions if you have any.
You can find me on Twitter as well under my last name. I tend to be incredibly slow because I'm normally on a flight, but I definitely respond on Twitter also. So thanks so much, and look forward to chatting with everyone soon.
Thank you for having me.
Yeah.